Hello everyone, this is M. Chiran from Sri Venkateswara College of Engineering, Electronics and Communication Department, 2022-23 batch. Now, my seminar topic is Quantum Computing Revolution. Now, I'm gonna explain about contents of introduction, history of quantum computing, objectives, necessity of quantum computing, methodology, applications, problems faced by quantum computers, results, conclusion. Coming to introduction, supercomputers are 100 times faster than classical computers, which are using today. The computers which we use are called classical computers, and supercomputers are way far ahead of them, which is 100 times faster. While coming to quantum computers, it is 15 crore times faster than supercomputer. You can imagine the speed of quantum computers. So we're gonna discuss what are the reasons behind the speed of it, and what are the problems faced by it, and in different ways how can the quantum computer use. Let us take an example. Drawing a deck of Drawing a cue from deck of cards. So normal computer, which means classical computer and supercomputers, you using same methodology which is represented here. In this computer, uh, in 52 cards, each and every card is checked whether it is queued or not. But in quantum computer, even 100,000, 1 crore cards, it can be detected in single try. So this is the supremacy of quantum computer. And classical and supercomputer uses bits, while quantum computer uses qubits, which is basically quantum bits. So we are going to discuss what are qubits in the next chapter. So quantum computers work on principle of two quantum theories, that is superposition and entanglement. So recently, Sycamore, a quantum computer built by Google, which has 54 qubits, can be able to perform a specific task in 200 seconds, which means 3 minutes 20 seconds. In this similar way, the same task can be completed in 10,000 years by a supercomputer. Coming to history, in 1982, Richard Feynman proposed an idea of creating mechanics based on the laws of quantum mechanics instead of the laws of classical physics. So he is the first scientist who said there is another field called quantum computers, quantum mechanics. So which can be implemented in subatomic levels. In 1985, David H. developed a quantum turning machine showing the quantum circuit are universal. So the figure here represents a normal classical gates, normal complex operation of normal classical gates. While in this figure, this similar way, quantum gates are represented. Here, the black dot is detection has been passed there, and input and output is based on superposition theories, which means this is only probability that an electron can be visible at a particular spot. So in next chapter we're going to discuss what is an electron, so what are subatomic particles, what are qubits, everything. In 1994, Peter Shor came up with a quantum algorithm to factor very large number in polynomial time. In 1997, Globe Gower developed a quantum search algorithm with O of root n complexity, which can be used in computers. So, coming to objectives, my objective is to understand the concepts of quantum physics, to analyze the needs and requirements of quantum computers, to study the real time applications of quantum computers, and to ensure the future using quantum supremacy. So, coming to necessity of quantum computer, why do we need quantum computers if we already have supercomputers and classical computers? So, the main reason, according to Moore's law, the transistor we gonna use it in processors to build a processors in both supercomputer, quantum computers, and as well as classical computers. So, year by year, within 18 months, the size is shrinking to half of the size. At starting in 1970, when Charles Babbage invented computer, the transistor size and computer size were too big as the size of a room. But now in 2020, the size came on decreasing, and it became to 2 nanometer. A single transistor became 2 nanometer in size, whereas our red blood cells is 7,000 nanometer. We can imagine how small this is. So this Moore's law, according to Moore's law, Slowing down in 2020, transistor per unit area reached its nearly to atomic stage, which means there is no possible way to reduce the size further. So if we reduce the size of transistor to below 2 nanometer, then quantum laws of quantum mechanics take over it. Eh, Quantum mechanics come into play. So my methodology is quantum mechanics or quantum physics help us to know about what's going in microscopic level. So this is the actual definition of quantum mechanics or quantum physics. In in subatomic levels, there exist neutrons, electrons, and protons. So these three particles are called subatomic particles, which cannot be even seen by strongest of microscope. The figure below is this is the hardest figure for human to capture. This is the actual representation of electron. Here, this electron, the electron showed here, the middle is nucleus, and the outer part is proton, and still outer part is electrons. The electron can be both wave and particle nature. So how can it possible? Wave nature means example of wave is radio waves, electromagnetic waves, infrared waves, so UV waves, etc., which cannot be seen by human eyes and which don't have any physical form. But an electron can be both particle as well as wave. So particle means which can be visible to human eye, even a slightest. Example, so sand in beach, or else dust particles in air. So electron can be at any space, any time, and anywhere in a particular moment of space in subatomic levels. So in first figure, so we don't know exactly how electron is present. So we're gonna detect it using subatomic detectors. So this is the actual definition of how electron behaves. So here we're gonna detect an electron by using its wave function, and by wave function we're gonna detect by only probability of electron in a particular time in particular space. We cannot detect completely and exactly where electron is. Science works differently in quantum levels, which means subatomic levels. So no theory is good there, which means E is equal to mc square proposed by Einstein is also disproven there. No other theories are possible in subatomic levels because it is way more complex to human brain to calculate these things. Even with advanced technology, we can't predict the exact location of electron. Only through the wave function, the best probability is obtained. Probability is obtained by squaring the amplitude of the probability of the electron in a particular time. So I already discussed about quantum computers uses qubits and classical computer and supercomputer uses normal bits. So coming to it, as we discussed, classical computers work on principle of classical bits, while quantum computer works on qubits. So here, a classical bit is either 0 or 1. For example, if we toss a coin, the probability of it is heads or tail. So first time it's gonna be head or tail. So second time it's gonna be same, output is same. So I'm gonna say probability of it is 50-50, which means 0 or 1. Or we can take another example of turning on a light and off. So let us consider the light is in off state, which means 0. And in the same way we can take a light in on state, which is represented as 1. So the output is one of the 2 power n probability permutations. But quantum bit means it is the probability of electron, so we cannot discuss exactly where is the position. So we're going to get a superposition state, which is represented as alpha of 0 plus beta of 1, which can be two states. In the same example, when we're tossing a coin, we're gonna probability only when we open our hands and see what is the outcome there. But the period which the coin takes to revolve in the air, that is the quantum bit. So I hope everybody got it. So next, to understand quantum computing knowledge on quantum mechanics is required. To know basic things about quantum computers, we must know the knowledge how quantum computer works, and to know how quantum computer works, we must know how quantum physics. So there are two laws in quantum physics, which is superposition and entanglement. So we already know what is superposition is, because right now I just said superposition allows quantum objects to simultaneously exist in more than one state or location. So I'm gonna prefer. Right now I'm in Bangalore. In the same time, I can't be in Andhra, in Telangana, or any other states, in any other place and any other part of world. I'm in Earth now. But I, at the same time, at the same moment of time, at the same second, I can't be in Mars. But the electron can be at any place in a particular orbit, which is it is revolving around the nucleus. So these quantum particles have potential to move everywhere, and it is visible only we detected it. So next is entanglement. It defines whenever two particles are created or any interaction is done between them, then a link is formed between them, between those two particles, which is called entanglement. So this we are represented here. The first figure represents how entanglement works. Even if the two particles, which is two entangled particles, are separated by millions of kilometers, millions of light years. So let us consider two quantum particles which is already entangled is placed in the one side of Milky Way, and another particle is placed in the another side of Milky Way. So the distance between them is almost infinity. So even though if the distance is infinity, the the properties of both quantum particles is completely opposite of each other, which means we have, if we can change the property of first quantum particle, similarly the second quantum particle properties will be changed. If the spin of first quantum particle is left and upward movement, in the same way the other quantum particle spin is downward and right movement. So this is entanglement. Even though it's separated from far away, we gonna know the output of another. We gonna know the state and positions of another quantum material by knowing the properties and by detecting the physical and its physical capabilities of one quantum computer. So in second figure, I represented a quantum position state where we gonna detect one quantum particle. So it is in the same way it is entangled with another quantum particle. So in this principle, our quantum computer works by observing the electron. Its superposition state is detected, and opposite is observed when it is entangled with entangled particle. Here, an output algorithm is given to an qubit output is obtained through its opposite side. So coming to applications. Quantum computers majority of applications in fields of artificial intelligence, chemical engineering, nanotechnology, bioengineering, transportation systems, etc. So now let us discuss the various fields where quantum computers can be used. Coming to artificial intelligence, the feedback is based on normal feedback is based on calculating the probability of how many possible choices, and so AI is an ideal candidate for quantum computing. So quantum computer can solve optimization problem faster than classical computer through the use of quantum approximate algorithm. So by using these algorithms, it can be much more way faster than normal classical computers. So next application is chemical engineering. So the impact of this is more efficient products from solar cells to pharmaceutical drugs, and especially fertilizer production. Since fertilizer accounts for 2% of global energy usage, quantum computing can improve R&D production and supply chain optimization in chemicals. So next application is cryptography. We all know how encryption works and how encryption provides security, and quantum computing uh, sorry, not quantum computing, its cryptography is much more efficient than normal encryptions we are using. Whenever we send money or receive money, so we're gonna follow an encryption algorithm such as 256-bit encryption, 124-bit encryption algorithms, etc. So in the same way, when it's come to quantum technology, here we're gonna use quantum cryptography, quantum key distribution techniques. So a supercomputer can solve an encryption code in 10,000 or million years. So, but quantum computer can solve the same algorithm within 10 to 15 minutes. This is to show how powerful quantum computer is. Imagine when these things get into wrong hand, what are the possibilities of data breaching, hacking? So to stop cyber attacks, quantum computing cyber attacks, another quantum computer is needed to protect them. So next application is finance. So financial institutions need to able to accurately access the management risk to avoid losses. Quantum computers can be used to stimulate and analyze large amount of financial data to identify potential risks and mitigate them. This can include stimulating market crashes or other disruptive events to develop effective risk management strategies. So the next application is intelligent transport system. Quantum computer is can be used as intelligent transport system by involving it involves finding the optimal route for vehicles or group of vehicles to visit multiple locations while minimizing the distance, time, cost, etc. This is complex optimization program. This can be solved using variational quantum eigensolver. So this is the algorithm which is used to detect and say what is the best way, and it also detect the driver behavior in particular moment of time, which can lead to reduced transportation costs and increase efficiency. Coming to last application, weather monitoring system. So quantum computer has the potential to significantly impact weather forecasting by providing faster and more accurate solution to complex programs such as weather pattern simulation, data assimilation, and weather prediction model optimization. Coming to result, quantum computers bring revolution to the world, and one day each and every problem will be solved by human intelligence through quantum computing. If quantum computers are so great, why aren't more industries using it? Why isn't every company had its own supercomputer or quantum computer? So there are few challenges that come with using quantum computers today. They are manufacturing stable quantum processor and error corrections. In order to take advantage of the properties of quantum mechanics, it is needed to perform manipulations at smaller scales, sometimes smaller than an atom. Small scales cause stability and error verification problems. Since qubits cannot be controlled with accuracy, it remains a challenge to solve complex problems. So, next problem faced by quantum computers is maintaining the extreme operating conditions. In order to increase stability and control qubits, IBM keeps temperature so cold, 15 millikelvin, so there is no ambient noise or heat to execute the superconducting qubit. Keeping the temperature so low also creates stability problems in itself. For broad commercialization of quantum computer, a processor operating conditions should be improved. So, getting to conclusions, quantum computers have the potential to transform computation by solving issues that were previously unsolved. A few major corporations and tiny startups already have working on non-zero corrected quantum computers with tens and thousands of qubits, and some of them are even available to the general public through the cloud. Scientists have recently demonstrated quantum teleportation by using electromagnetic photons to create remotely entangled pairs of qubits. Qubits made of individual electrons, however, are promising for transmitting information in semiconductors. By 2020, fully functional quantum computer will come into existence and solve problems beyond human comprehension. So this is the conclusion. Coming to reference, I took reference from these papers, which is recently published from year 2022-22. So thank you.